Today's objective, NH20, describes sources and health effects of radiation. Radiation is energy in the form of waves or high-speed particles. On the electromagnetic spectrum, we can see that radiation goes from low energy and large wavelengths in radio waves to very short wavelengths and high energy in gamma rays. We're going to see how those different types of energy affect the body. Radiation is all around us. We are naturally exposed to radiation every day. In the rocks and soil that make up the earth, to the food that we eat and the air that we breathe. Radiation is constantly coming to us through the atmosphere from outer space. However, man has also made many uses of radiation, from nuclear power and nuclear testing to many medical procedures that use radiation to keep us safe. We're going to see what happens, though, if we are exposed to too much radiation. First, non-ionizing radiation has low frequency wavelengths. This has low energy. It's used in microwaves to heat food and in radio waves. It poses little threat to our health. However, ionizing radiation has energy that can break chemical bonds. This comes from UV radiation from the sun, X-rays, and radon, a radioactive, colorless, odorless, tasteless gas that occurs naturally as uranium breaks down in rocks and soil. Radon can build up in homes and workplaces, resulting in it being the second leading cause of lung cancer in the United States. Radon is dangerous because it's inhaled into the lungs where it affects those tissues. Remember, ionizing radiation has high energy. There are three types of ionizing radiation. Alpha particles, which are made of 2 protons and 2 neutrons, emitted or released by radioactive decay that can be shielded by thin layers of light material. They do not pose a direct external threat because usually clothes can protect the human body from alpha particles, but they are dangerous if they're inhaled or ingested. Beta particles are an electron emitted from radioactive decay that can be shielded by aluminum. They can pose a serious direct or external radiation threat and can be lethal depending on the amount received. They also pose a serious internal radiation threat if inhaled or ingested. Gamma rays are the most powerful type of radiation. They're high-energy photons emitted by radioactive decay. Exposure can result in radiation sickness, but can be shielded with lead. Again, we see that alpha particles are the lowest energy. They can be shielded with paper. Beta particles are the next highest in energy. They can be shielded with aluminum. And gamma are the most powerful, which can only be shielded with lead. The health effects of radiation depend on the amount that you are exposed to and the areas of your body that are exposed. However, we can see with radiation sickness the immediate effects of vomiting and diarrhea, bleeding, reduction in blood cells, and damage to blood-producing cells in the bone marrow. Exposure to radiation over a long period of time, or the delayed effects of high-dose radiation exposure, can involve cataracts of the eyes and genetic damage. Radiation can change the DNA of our cells. This change can result in cancer. The cancer is usually a result of where you are exposed to the radiation. We know that UV radiation can cause skin cancer when that radiation hits our skin cells. Radon that's inhaled into the lungs can cause lung cancer as radiation comes in contact with the lung cells. An ingestion of radioactive particles can cause cancer of the intestines and the digestive tract. Also, anemia can result from the loss of white blood cells. Finally, people can become temporarily sterile, meaning they wouldn't be able to reproduce or have children. Remember, we said that we're exposed to radiation all the time. Here's an example of the different amounts of radiation that you can be exposed to in different circumstances. Here we can see that smoking 1 pack of cigarettes per day for 1 year results in more radiation exposure than the average radiation dose of people exposed to the Chernobyl disaster, which was a nuclear meltdown. Many of us have probably had a chest x-ray. We know that many times lead is used to help protect us from the radiation from that x-ray. Finally, we've been hearing in the news about nuclear meltdowns. What actually happens in a nuclear meltdown, and how can that contamination spread? These are dangerous because if a nuclear plant melts down, the radioactive material is released into the atmosphere. That can spread through air and precipitation, resulting in direct radiation exposure to people, or in contamination of our food and water supplies, which can then be ingested or inhaled. However, it is good to know that danger from the radiation source will decrease with distance. So the farther you are away from the initial nuclear plant, the less risk you have of radiation exposure. Okay, we'll be talking in class tomorrow about sources of health and health effects of radiation. So make sure these notes are thorough so you're ready for class tomorrow.